Welcome to the Chapter 8.1 lesson video. We're going to be talking about complex and imaginary numbers today. Now, this is a topic that you did back in Integrated Math 2, so it should seem fairly familiar, but it's been a little while. It's something we'll talk about today, and we're also going to talk about it a little bit more the day we come back from spring break. But for now, we're going to dive into it, learn a little bit, and then we'll refresh a little bit more later as well. All right, today we want to talk about how we can do operations of addition, subtraction, multiplication, division with complex numbers, and also talk about the powers of I and how to simplify those powers of I. All right, so first and foremost, we'll talk about simplifying radicals. This is something all of you are fairly familiar and pretty good at. If you had something like 18x squared y, we could break that down into its prime factors. 2 times 3 times 3 times x times y. 3 times 3 is 3 squared, and the square root of the 3 squared can become a 3. X times x is x squared, and the square root of the x squared part can become just x. The 2 and the y are not perfect squares, and so they remain inside the radical. Now, this is something you guys have been doing for a while. This is something you're familiar with. I imagine that if I asked any of you guys to simplify a radical, you could do something similar, and you might not even need as many steps to do it. Now, this is another concept that we break down for you guys in Integrated Math 2, talking about the different number systems. Everything we do is, or majority of everything we do is what's called the real number system. The real number system is really anything you can think of. There are two kind of subcategories in that. The biggest one, the main one that we operate in a majority of the time, is called the rational number system. The rational number system are numbers that are anything that can be written as a fraction. So rational numbers are anything that can be written as fractions. Integers are any numbers that are positive and negative counting numbers. So from negative 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 to positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Any of those positive and negative counting numbers are called the integers. The whole numbers are our counting numbers, our positive counting numbers and 0. And then the natural numbers are just our positive numbers. On the other side of the real numbers is what's called the irrational numbers. These are the things that can't be written as a fraction. Repeating decimals and things like pi and e are all irrational numbers. So this is what we're familiar with. This is a majority of what we use, but that isn't the only thing that we interact with. We also have imaginary and complex numbers. And so that's what today is going to be about, is imaginary and complex numbers. Imaginary numbers and complex numbers are things dealing with I. And so let's get back in. So the number I is a number such that when we square it, it equals -1. So with a little bit of simple math, if I squared equals -1, then that means that I alone is equal to the square root of -1. Now, for a long time in your guys' math career, the square root of -1 was a big no-no, and we often had square roots of -1, and we say they were undefined. That's in the real number system, but then we introduce these complex numbers to you, things involving I, and you're allowed to take the square root of a negative now. So adding on to what we talked about earlier, if we're simplifying a radical and we have a negative on the inside, then we can pull that negative out as I, as a square root of -1, which is I. So, for example, if you have something like this, if you have something like the square root of -70, we could change that into -1 times 2 times 7 times 5, and that would multiply out to be -70. Now, there's no perfect squares here. There's no pairs of numbers or things that can be square rooted, but there is that -1, and we can pull that -1 out as the number I. So we could rewrite this as I times the square root of 70. The next one down here, the square root of -48, we can rewrite that as the square root of -1 times 2 times 2 times 2 times 2 times 3. So -1 times 2 times 2 times 2 times 3, and then we can find all our perfect squares. So our perfect squares are groups of 2 of the same things. We have 2 2's, we have another 2 2's, and then we also have this -1. So each of those 2's can come out. So the square root of 2 squared is 2, the square root of 2 squared is 2, so there is a 4 that gets to come out. The square root of that -1 becomes an I, and then the 3 doesn't get to come out, so it stays a square root of 3. All right, so just like simplifying before, very similar. It's just now when we have that negative on the inside, we can pull it out as I. All right, so a complex number, an imaginary number was a number with I. A complex number is a number that is made up of 2 parts. The first part is called the real part. The real part is anything from the real number system. The second part is called the imaginary part. The imaginary part is something with an imaginary number in it, I. So there are 2 parts, the real part, the imaginary part. Together, they make what's called a complex number. So a complex number is a combination of real and imaginary numbers. Now, one thing we haven't tackled this year is what happens when we have real and imaginary numbers in trig. And so that's what this whole chapter ends up being about. What do we do with I in trigonometry? And that's a little bit weird. It's a little bit strange. It's not something that you don't really think about right off the bat, but it's something that mathematicians have come to figure out. Okay, so first thing we got to do is kind of break down the basics of these complex numbers. So all the basic operations, when it comes to adding and subtracting, adding is just like combining like terms, like with variables. If I have a plus bi and I'm adding c plus di, I can combine the a and I can combine the c. I can add those 2 things together because those are both real parts. And I can combine the bi with the di because those are both imaginary parts. So I can combine the real with the real and the imaginary with the imaginary. When it comes to something like the subtraction problem here, first thing we have to remember to do is we have to distribute this negative. So the way I like to do that is change it to addition of the opposite. So I change it to a plus sign, and I change both of these to be their opposite values. That's one way to do it. And then I just combine them like I did before there. So my a got mixed with my minus c. So I have a and minus c. And then my bi got mixed with the negative di. So bi got mixed with negative di, so I had the b minus di. Same idea, you just have to remember to distribute that negative there. So that's the one important thing that's kind of different between addition and subtraction. Otherwise, it's just combining like terms. You just combine the real stuff with the real stuff and the imaginary stuff with the imaginary stuff. It's pretty straightforward, and it's something most of you guys are fairly comfortable. Let's go ahead and try a couple of them real quick, just a couple practice problems. So this first one here, we're going to distribute the negative. So I'm going to make that a plus, minus, plus. So everything becomes opposite after that negative gets distributed through. And I'm going to combine the real stuff with the real stuff and the imaginary stuff with the imaginary stuff. So real with real, imaginary with imaginary. All right, so my real stuff plus my real stuff, I get 18 plus negative 7, that's 11. And then negative 2i plus positive 5i is positive 3i. There we go, pretty straightforward. The next one's already addition, so I'm just going to combine the real with the real. And I'm going to combine the imaginary part with the imaginary part. Combine them together, so I get negative 3 plus negative 14 is negative 17. And 2i plus 5i is 7i. So real with real, imaginary with imaginary, combine them together. Multiplying is a little bit different because when we multiply these complex numbers, they're kind of binomials. So remember, when you multiply stuff, you have to distribute. So you have to do a times c, you have to do a times di, you have to do bi times c, and you have to do bi times di. Now, when you do this bi times di, you end up multiplying the b with the d, the coefficients, but you get I times I. Well, I squared, by definition, is equal to negative 1. So when you get this I squared here, a lot of times you'll see me circle it, and then I change the sign out in front to be a negative, or the opposite of what it was. And so this is one thing you have to pay attention to when you're multiplying your complex or imaginary numbers, is that I times I, by definition, I squared is negative 1. So we change it to a negative 1. And then the nice thing is it's now a real number, so it can mix with this other value that doesn't have an I out in front. All right, so we got 2 example problems to try of that. The first one's a little bit easier of a distribution than the second one. So the first one, we're going to distribute 10i times 7 and 10i times negative 5i. So we go ahead and multiply those. So 10i times 7 and plus 10i times negative 5i. We multiply these both out. 10i times 7, that becomes 70i. Plus 10i times negative 5i, that's going to become negative 50i squared. Now, we just mentioned something about this. I squared is negative 1, which means that this sign in front of it becomes opposite. So we end up with a positive 50 plus 70i, right? So that I squared changed our sign. Now, the only thing that's different about the next one is there's just more to distribute. So we do 3 times 4. 3 times 4 is 12. We do 3 times 5i. So if I have 3 5i's, throw 5i 3 times, we have 15i. And then we have 2i times 4. So if I have 2i 4 times, that means I have 8i. And then if I have 2i times 5i, that means I have 10i squared. And this is that thing we're paying attention again, because it's 10i squared. That I squared is going to become a negative 1, which is going to change the sign in front there. So it's not really a positive 10, it's a negative 10. So you have positive 12 and negative 10 is 2. And then 15i plus 8i is plus 23i. So be really careful there. When you get that I squared, it's got to become a negative 1, which changes the sign, which means you can now combine it with the other real number, this 12 that was in front, and it changes and simplifies things down a little bit. All right, another thing that we talk about back when we do these chapters is the powers of I. The one that we're given, the one that's our definition, is that I squared equals negative 1. That's the one we start with. That's kind of our definition. There's another one that kind of, or a couple of the other ones actually make a little bit of sense just straight up as well. Anything to the first power just stays itself. So I to the first power just stays itself, stays I. And anything to the 0 power becomes 1. So I to the 0 power is just 1. Now, I to the third, we can kind of figure it out a little bit logically. I to the third can be made up of an I times an I squared. So if we look at those two things, I and I squared, well, I squared is a negative 1, and I to the first, or I, is just I. So negative 1 times I makes negative I. And so we can kind of logically conclude that. Well, these are the only 4 possibilities. After I to the third, I to the fourth is going to repeat and go back to the value of I to the 0. I to the fifth will be the same as I to the first. 6 will be the same as the second. 7th will be the same as the third. And it just keeps repeating over and over and over and going back. Well, since there's only 4 possible values, and those values are 0, 1, 2, and 3, when I get something like I to the 47th power, I really just need to look at the remainder. So in order to do this, what you're going to do is just a little bit of side scratch work. So you say, all right, I have 47, and I want to divide it by 4, because there's only 4 possibilities, 0, 1, 2, and 3. 4 goes into 4 one time. Drop down the 7. 4 goes into 7 one time. 7 minus 4, minus 4 gives me a remainder of 3. So this remainder of 3 means that I cycled around 11 times and I had 3 left over. So that means that I to the 47th is the same as I to the third. I to the third is negative I, and that's my simplified answer. So I to the 47th is really I to the third, which is really negative I. And I got that just by looking for the remainder. All right, so if we had these real quick, it's really just as simple as dividing by 4. So we just say 15 divided by 4. 15 divided by 4. 4 does not go into 1. It does go into 15. It goes in 3 times. So that's 12. 15 minus 12 is 3. So I to the 15 is also the same as I to the third, which we've memorized is negative I. What about 936? So 4 goes into 936. Let's see, it goes into 9 2 times with 1 left over. Drop down the 3. It goes into 13 3 times. That's 12 with 1 left over. It goes into 16 4 times evenly. So there is 0 remainder. So 936 is the same as I to the 0 because there was no remainder, and anything to the 0 power is 1. So by doing this divide by 4 thing and looking at the remainder, we can pretty easily figure out what the value actually is of those 4 initial powers of I. All right, we have just a couple more things when it comes to complex numbers. One other thing that you're going to see in complex numbers is something called the complex conjugate. Now, this is kind of a handy tool to be able to use when it comes to complex numbers, is that for every complex number that we have, we can multiply by something called the complex conjugate, and it'll cause a complex number to become a real number. In other words, the I part will go away. So a complex conjugate is whatever our complex number is, except the sign in between the real and imaginary piece is opposite. So the imaginary part is opposite. So if I have a plus bi, its complex conjugate is a minus bi. 5 plus 3i is 5 minus 3i, and vice versa. Now, if we multiply these out, watch what happens. 5 times 5 is 25. 5 times negative 3i is negative 15i. 3i times 5 is positive 15i, and 3i times 3i is negative 9i squared. So check out a couple things that are about to happen. Positive 15i and negative 15i cancel each other out. I squared becomes a negative 1, which turns this negative in front into a positive. So we're left with just 25 plus 9. 25 plus 9 is 34, which is no longer a complex or imaginary number. It is now a real number. In fact, what you'll notice is that it's always just a squared plus b squared. So whatever the coefficients were back here, a and b, if we square those two numbers and add them together, or in this case it was 5 and 3, if we square those two numbers and add them together, and when we're multiplying by the complex conjugate, it'll give us what the answer is. Now, this is really helpful for this next problem we're going to solve. When we're trying to get rid of a complex number in the denominator, we can use this complex conjugate method to simplify it down and get rid of it. All right, so let's do exactly that. So I have 5 over 3 plus 2i. I cannot have this in the denominator because I is technically a square root. I is the square root of negative 1, so I can't leave that square root on bottom because that's a big math no-no. So in order to get rid of that, I'm going to multiply by 3 minus 2i on top and bottom. If I multiply by 3 minus 2i on top and bottom, it'll get rid of that imaginary number. Now, we just said on bottom, it's going to become the first thing squared, 3, plus the second coefficient, 2 squared. So it's going to be 3 squared plus 2 squared on bottom. On top, we do have to do a little distribution. 5 times 3 is 15, and 5 times negative 2i is negative 10i. All right, just a little more simplifying. 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. So we end up with 15 minus 10, minus 10i over 13. Now, that's not usually the way we leave it written. We usually simplify it out and spread it out a little bit into the real and imaginary parts. So we usually write 15 over 13 minus 10 over 13i. And that would be our final simplified divided answer. All right. So with that, you should have enough information to be able to get started on the homework assignment. This homework assignment here is pretty short and easy. We're going to review all of this and practice all of this as well, again, after break. If you have any questions, please reach out to me. Otherwise, I'll see you guys in our next live session. And until then, I hope you have a great day.